Okay, so adding and subtracting. So like anything else, you've got to completely factor numerators and denominator. Or sorry, in this case, unlike everything else, you completely factor the denominator. You can leave the numerators alone. Once we have the factored form of the denominator, then we state the restrictions or the non-permissible values. So state restrictions. You might see a lot. They might word it as the non-permissible values of blah blah r, right? In which case you would write it as x equals instead of x is not equal to. So for restriction, we always write it as x is not equal to. And for non-permissible values, we're at x equals to. So state restrictions, that comes from the factored form of the denominator. Right, there's no division here, so we're not worried about anything changing to a multiplication and a numerator moving down to a denominator, right? That doesn't happen in adding and subtracting. You have to determine the lowest common denominator. So in order to add or subtract fractions, that relies on the lowest common denominator. So once you've got a factored form, then it's easy enough to look at it and say, okay, this will be the lowest common denominator. Then what we're going to do is, going back to day one, we're going to express the rational expressions as equivalent rational expressions, right? So we may have to change it. And I'll show you what I mean just with regular old fractions in a moment. But so express the rational expressions. So you're going to have at least two of them, right, if you're adding or subtracting. As equivalent rational expressions with that common denominator. So sometimes we just get to leave one of them alone and we only have to change the other one, and sometimes we have to change them both. Okay, and they're going to become more complex, right? But we're always going to leave things in a factored form at this point. Until step 5, which is add or subtract the numerator. And we leave the denominator the same, right? Keep the LCD. Okay, so we're factoring everything, we're stating restrictions from factored form, we're figuring out what is the lowest common denominator, we're rewriting one or both of the rational expressions so that they will have that common denominator. Then we can play with the numerators. We add or subtract them, right? We do it. We collect like terms. So collect like terms in the numerator and simplify. Let's just say and express as a single rational expression. And express as a single rational expression. I'll abbreviate as RE, and then we simplify if possible. Okay, so it sounds like a lot, and sometimes it is, but you know, it's a fairly, you know, the process at least of factoring denominators, we just do that with everything. State restrictions from the factored form, we do that with everything. Okay, now we get into the special stuff. Determine the lowest common denominator. It doesn't hurt for you to state it at that point, right? Just to write it down. My LCD is blah, right? Because then that tells you, okay, what do I have to do then in step 4 to get equivalent rational expressions where they both have that common denominator, right? Then we add or subtract, collect like terms, express it as a single rational expression, and then the very last step is just to see, is there anything that cancels? Maybe I now have a common factor top and bottom, and I can do some cancellation. All right, so do some examples from simple to complex. One, just starting off with just remembering, how do we add fractions? Right? Because rational expressions are just fractions, right? But they're algebraic fractions. You can have polynomials. All right, so what if I want to add 3/5 plus 1/2? So the instructions will always still be simplify. So what don't we do? Well, we don't just go and say 3 plus 1 is 4 and 5 plus 2 is 7, and so the answer is 4 over 7. Right? We know not to do that, hopefully. So instead, we need a common denominator, which is going to be what? 10. So then you say, well, how do I turn 3 over 5 into something over 10? Well, to get a 10 on the bottom, I'm going to multiply by 5 times 2. That'll give me 10. If I multiply the denominator by 2, what do I do to the numerator? I multiply it by 2 as well, right? So we have to multiply by, now what's 2 over 2 equal to? 1. So we're multiplying by 1, right? You multiply something by 1, you're not changing its value, right? 1 times anything is just the thing. But we are changing its form, right? We're changing it from fifths to tenths. And I've got the 1/2. So 2 times what is going to give me 10? Let's say 5. So put a 5 down there. What do I put up top? Also a 5, right? So now this becomes 6 over 10 plus 5 over 10, which is equal to what? 11 over 10. And generally speaking, we're just going to leave it in that form, right? We don't like mixed numbers, 1 and 1/10, right, or 1.1. Okay, so we do basically kind of the same thing. Let's say I want to do this. 3 over 5x squared plus 1 over 2x. So first thing, was there anything to factor? No. Nothing to factor, so we go to step 2. What are the restrictions? Okay, so x cannot equal 0. Now in the diploma, they like asking about non-permissible values, in which case you would say the non-permissible value is x equals 0. I mean, in a sense, you're not really going to have to worry about it because you're not actually writing stuff down, but you're answering questions that may say the non-permissible values are, and you get x equals 0, x equals 2. You know, you have 4 choices and you choose which of the 4 it is. And, you know, and some of the questions really are that easy, right? Like they are just a pretty straightforward question. And others, you know, you might have to run a regression. You're going to have to, you know, it's going to take a few minutes. And the puzzle questions, you know, nobody knows what they're like. I mean, you know, it could be anything. I'm going to give you a package. Maybe next week we'll just do a day on puzzles. So just hand a package of puzzles to you that you can work through. And, you know, you're probably going to see questions of that nature on the diploma and on the field tests and stuff. Okay, what's our LCD? 10. What else? I see an x squared down there, so got to be some variable. So it's 10 x squared. So we need a number that both the numbers go into, right? So the lowest common multiple of 5 and 2, which is 10. And we need the variable of highest degree, right? So this is an x, this is an x squared, this trumps it, it's bigger, so we need x squared. So how am I going to make this 10x squared? What do I do to 5x squared to get 10x squared? Multiply by 2.
With William Crochow and Ivan Pico, please go to room 103. William Crochow and Ivan Pico.
So when we do that, remember what we want. What do we want? An equivalent rational expression whose denominator is 10x squared. So we say, all right, well, we got 5x squared. We're going to multiply it by 2. That'll give me 10x squared. But to make it equivalent, I have to multiply it by 1, right? But we do 1 in the form of 2 over 2. Plus, okay, I got 1 over 2x. So what do I have to do to 2x to get 10x squared? Multiply by 5x, right? So that, and what goes up here? Another 5x, right? So 5x, 5x. Okay. Now, you know, there's shorter ways of doing this, but, you know, we'll stick with the long way. It's, you know, it's not a huge part of the course, right? I mean, it's like one day, it's one objective. It could be 1 or 2 questions on the test on this, right? So, you know, we don't necessarily need to worry about efficiency, more worry about understanding. And just, okay, if I always go through the same process. All right, what do we got here? We get 6 over 10x squared plus 5x over 10x squared. Okay, now we could, if we wanted to, write that as 6 plus 5. Now that I've got the common denominator, you know, I could just write it once and just put the expression that's up top, right, which is now 6 plus 5x. You're wondering, what happened to the x? And that's actually just the answer, right? 6 plus 5x over 10x squared. There's nothing else you can do with that. These guys are not like terms, so you can't collect them. They don't have a common factor. Okay? Like if they had a common factor of 2, I could take that out and then cancel it with the factor on the bottom, right? So that's what I mean by the last step of simplify if possible. Oh, it might be that, hey, I got to, you know, these are both even, and I can divide that with this, and it will simplify down a little bit simpler. Okay, so here it is, it's just fractions, right? We get 11 over 10, and here 6 plus 5x over 10x squared. Okay, same restriction holds, right? X cannot equal 0. All right, what do we got? 27 pages more now. So it's just along those lines. Why don't you try this one? Okay, so that's what you've got. Start off, state the restriction, which, yeah, is pretty. write down what your LCD is. Okay, so what am I using? Then figure out, okay, what do I have to do to each of these guys to get the lowest common denominator? Right, what operation do I have to do? So I'll give you a head start. X minus 3. Okay, so my LCD, numbers, my lowest common denominator is going to be 8x squared, right? 4 and 8 both go into 8, okay? So the 4x needs to be multiplied by 2x, and a 2x here as well. Minus, this sign just comes down, and 3 over 8x squared. It already has the denominator I need, so we don't need to adjust it. We don't need to do anything to it. So I get 2x over 8x squared minus 3 over 8x squared. And now that they have a common denominator of 8x squared, I only need to write it once. And the expression is 2x minus 3 over 8x squared. 4, 5. Okay, let's do one where we're going to have x's and do adjustments to both again. I'll show you a couple ways you could do this. Okay, so 4 over 12x squared plus 3 over 5x. Well, we're going to start with, okay, nothing to factor. So now figure out what is my lowest common denominator, or what is the lowest common denominator. Then you say, okay, what do I have to do to this expression to get 60x squared on the bottom? Multiply by 5. Okay, remember, we're just back to day one, right? Just equivalent rational expressions, right? That's all you're doing, equivalent rational expressions. Okay, so I end up with 5 plus 9x over 15x squared. So you got to practice these, right? I mean, you have to get in there, get your hands dirty, and work questions, and you don't have to do them all, but you have to do enough. As you may notice, some of the questions on the quizzes are taken out of the textbook, so they're just questions that you've already worked in the textbook. So in this case, there was some simplifying at the end. Actually, there was some simplifying at the beginning. that I could have done. Anybody see what I could have done at the beginning? What can you do with 4 over 12x squared? You can make it 1 over 3x squared. See, that'll make life a little bit easier, right? Make all the rest of the numbers a little bit easier. So we'll flip to the next page. And I'll just show you. Okay, so what if we recognized that 4 over 12x squared plus, what was it, plus 3 over 5x. So before we do anything, we say x can't be 0, right? We state our restriction, and we say, but 4 goes into 12 3 times. So this is 1 over 3x squared plus 3 over 5x. And now our common denominator becomes 15x squared, right? Like right off the bat. Instead of 60x squared, and then we got to factor 4 out of everything and simplify, if we can recognize that, hey, this simplifies, just makes things easier down the road. So the LCD is 15x squared. Okay, and again, so how do I get 15x squared? I need a 5. Just 5, that'll give me 15x squared. And how do I get 15x squared here? Well, I need a 3 to get 15, and I need an x to get x squared. So this becomes 5 over 15x squared plus 9x over 15x squared. Common denominator is 15x squared. And the expression here is 5 plus 9x, right? And then, is there anything that cancels? No, because there's no number that goes into 5, 9, and 15. Right? Whereas back here, we had to say, hey, wait a sec. That's divisible by, well, at the very least, they're all even, right? So they're all divisible by 2, but then they're all divisible by 2 again. Each of these are divisible by 4. So we needed to factor a 4 out of the numerator and then cancel that with the 4. We could also write this as 4 times 15 and then just cancel the 4s and get down to this. Okay, so either way, you're getting the same answer, right? There is only one simplified solution. Okay, so when you're writing any of the tests, if it's multiple choice, only one of the answers is correct. Okay, if you're thinking there's more than one, then you've made a mistake at some point. School, we can have fun going on, not within earshot. Okay, give that one a shot. 9 over 8x plus 3. My first step is I want to write that as a fraction then, right? I'm going to add 2 fractions. They should look like fractions. And we haven't done any factoring yet. Okay, and 1, 2, 3, done. Okay, so if you're adding just a number, like 3, then write it as 3 over 1 so it looks like a fraction. Okay, then figure what's my lowest common denominator, right? After you do restrictions. So restrictions first, what's the lowest common denominator? Okay, now you're not likely going to get many questions that look like any of these, right? But it's building up to something that looks like this. So here's a binomial. binomial, right? What special considerations what do we have to watch out for when we're dealing with the binomial in this case? Okay, so we got a set of brackets. We need to remember, we're going to multiply a set of brackets by a number that number is going to distribute through the brackets, right? You've got to remember to do that. So start off with the usual. Okay, so P can't be 0. What's my LCD? So if I want to figure out the LCD, what I do to figure out the LCD is I take the bigger number and I start taking multiples of it. So does 6 go into 10? Nope. 6 go into 20? Nope. 6 go into 30? Yep. Okay, so 30 is it, right? No point worrying about multiples of 6, right? You sit there and go 6, 12, 18, whatever, right? They need a common multiple, so deal with the biggest number, right? I mean, 10 is not going to go into 12, it's not going to go into 18, right? It won't go into a lot of the multiples of that. And you'll be checking, 12, 18, 24, 30 before you get there, as opposed to 10, 20, 30. Okay, so 30, and what's the power of P? Squared, right? So the larger power. Okay, so we got 2P plus 5 over 6P squared times. So to get 30P squared, I just need a 5, right? 6 times 5 will give me 30. I've already got the P squared. Minus 3 over 10P. So 3P and 3P. Okay, so that'll give me 30P squared. Okay, so now we've got the 5 times this set of brackets, right? So it's 5 times 2P, which is 10P, plus 5 times 5, which is 25, over 30P squared, minus 9P over 30P squared. All right, you have a common denominator, so you can just write it once, 30P squared, and then we've got 10P plus 25 minus 9P. Which is equal to P. So 10P minus 9P gives you 1P. Plus 25 over 30P squared. Okay, nothing cancels, it's just the number 1. So there's no common factor. If that had been a 5P or something, then I could factor out the 5 and cancel it. One of the reasons I show all the detail this way is oftentimes you're going to get questions like on the last quiz where it said, where's the mistake? It always used to be step 2 or 3. Now it's often step 1. So watch out. Sometimes the mistakes are just in the first step. Just we were writing a question yesterday, which I mean it won't be on the exam, but one of the questions that somebody wrote was put the error in step 1. So if you know the steps. And the way that the steps are shown might be a little different from what's shown up here, right? It could be a variation of it, but this is kind of the most detail that you'll see. And a lot of times when they're asking questions, they're showing detail in the solution, right? Like here's a detailed solution, as opposed to here's just something kind of worked out. Okay, do that. And recording now. Okay, and there's the solution to that. Pause, look at it if you need to. Okay, so this one, 2 different binomial denominators. Nothing to factor, it's in factored form. So what are my restrictions? -2 and -4. Okay, now I'm going to add one thing to them. Anytime I see a binomial, I'm going to put brackets around it, right? So just need to be reminded that it's really a single term. X plus 2 is really a single term. So if you know what x is, you're just going to add 2 to it. But, you know, we don't. We just want to be reminded that if we do, then we have to do that. What's the LCD? You just look at the terms, right? You just say, okay, I need one of these in the denominator. And I need one of these in the denominator. Now, if you think about it, that's not much different than saying, well, I've got a 6 and a 10, so, or not 6 and 10, let's say a 5 and a 2, so I need both a 5 and a 2 in the denominator. Go back to the very first one we did, right? What was the lowest common denominator? 5 times 2 or 10. What's the lowest common denominator? X plus 2 times x plus 4. So now, we're going to take this term, 3 over x plus 2, and we got to multiply it to make an equivalent rational expression whose denominator is x plus 2 times x plus 4. So we're going to put an x plus 4 down here. So what goes up here? No, what goes right in that spot there? X plus 4, right? Because what are we always multiplying by? 1. So that's how we're going to get 1, right? X plus 4 over x plus 4. What's that equal to? 1, as long as x isn't negative 4, right? Which we've taken care of up there. Plus, we're only halfway. So what do we multiply 5 over x plus 4 by? X plus 2 over x plus 2. Anytime you write a binomial, make sure that you enclose it in parentheses, right? Now, when we do the denominator, we're not going to expand it out, right? We're never going to expand a denominator out. We will factor them. We will not expand them. Okay? So we're not going to write it as x squared plus 6x plus 8. You will not likely see it written that way. You might, but you know, if you're doing a question in multiple choice, you look and all the denominators are expanded out, then you're going to have to expand yours out. Okay, but in general, we're just going to leave it. So I now have a common denominator, which is x plus 2, x plus 4. Okay, so I'm only going to write that once now. Okay, and now I'm going to do the 3, so what's up top? Well, we've got 3 times x plus 4 plus 5 times x plus 2. So that's what's up top. Now we have to expand and simplify the numerator, okay? Because we have to get that collected down into, you know, whatever terms it's going to be. So we go through, we get 3x plus 12 plus 5x plus 10 over x plus 2, x plus 4. So the denominator isn't going anywhere, right? Like it can't disappear because it's got nowhere to go. There's no equal sign, right? Like, you know, we're going to do one where we will solve a rational equation where we'll say 3 over x plus 2 plus 5 over x plus 4 is equal to 17 or something, then say solve for x. Then denominators go away. But in adding or subtracting, they're always there, right? And just in factored form. So we get 8x plus 22 over x plus 2, x plus 4. Now you could say, hey, 8x plus 22. They're both even. You could take out a 2, right? You could write it as 2 times 4x plus 11. I'm not going to, and the reason I'm not going to is because if I take a 2 out, it's got nowhere to cancel, right? If I end up with 2 bracket 4x plus 11 bracket, there's nothing that cancels, right? 2 doesn't cancel in any of these. If I have 4x plus 11, it's not the same as either of these guys, so I can't really simplify it any further. So that's where we stop, right? But we need to look at this just in case one of the factors would cancel with one of these factors, right? That's the very last step, the simplify. Is just, can anything cancel? You look at, yeah, no, it's not going to happen. Okay, so I can leave it there. Okay, any questions on this? Right, so there's your concept of we need that common denominator. Okay. Do another few. All right, so I've given this to you in a factored form, at least the 2 times y plus 1. I've got a binomial sitting here, so I'm going to put brackets around it just to remind me, hey, that's a single term, right? There's nothing separate about it. I can't take the 3 and divide it into stuff. Right? Now, watch your variables. I haven't been, like deducting marks when you said x can't be 0, but there was no x in the question. It was like an a. You should be saying a cannot be 0. In this case, y cannot be. What can y not be? Negative 1. And? So negative 1, negative 1/3. I realized as I was marking the stuff on Friday and Saturday that I was making life way too difficult on myself, and that I'm going to cut it down and just say this is wrong, therefore the whole thing is wrong, right? It's like, oh, you misstated the restriction, and the rest of it could be right, but I'm just going to mark it wrong. So it's wrong. And then you get to fix it if you want, right? You could say, what did I do wrong here? It's nothing. Your restriction is wrong. The 6 lines of algebra leading to the simplified form are beautiful. The restriction's wrong, so the whole thing's wrong, right? And I can do that, right? Because, I mean, on a normal test, doing that and saying you get 0 out of 4 for that is like patently unfair. It's like the only thing you had wrong was like something that's worth a half a mark. But I realized, why am I sitting there making this big distinction? It's wrong, right? It's wrong. Redo it. Fix it. Get it right. You only get, I mean, any part of the diploma, you get any part of the question wrong, how many marks are you going to get? 0. There's no half marks, right? So each of those 40 questions, you do one little step wrong. No point in giving you, oh, that's worth like 1 out of 4 or 3 out of 4. It's worth 0 out of 4. Or sorry, 0 out of 1. Anyway, all right, what's the LCD? Okay, write it down. Write down what you think the LCD is, then I'll tell you why you're wrong. Or not. But if you're going to be honest, at least half of you will get it wrong. Which is good, right? This is the place we make the mistakes. I won't ask you by a show of hands. You don't have to say, oh, I had it, unless you want to. You can say, well, I got that one wrong. Here's the LCD. Okay. There's the LCD. How many of you will admit to getting it right? How many of you will admit to getting it wrong? That's fine, right? This is the place to get it wrong. Okay, so the way it works is you need one of everything that's down there, right? You need a 3y plus 1. You need that 2. You need a y plus 1. Okay? If there were an 8 up here or something, I could cancel that, right? Do that ahead of time. Like that would make life a lot easier, right? Like we saw in that other one. Okay, so now, right? Now you just got to slug it out. So you say, okay, well, I got this. What do I need? Okay, I got that. So I need a 2 and a y plus 1, right? So I need a 2 times y plus 1. And then up top, I need a 2 times y plus 1. Okay, because this is always equal to what? And by this, I mean this, if you happen to be watching that, right? That's always equal to 1. Okay, plus, then we just pull that sign down, and we got 1 over 2 times y plus 1. Okay, so what does it need? Well, I got one of these, and I got one of these, so I just need this, right? That's why writing this out is handy, right? Because you can look at it and say, got it, need it, okay, 3y plus 1. Okay, brackets around all the binomials. Okay, so I'm going to do this. I'm just going to write out one denominator, right? It's common now, so we're just going to put down the common. So 2, and a y plus 1, and a 3y plus 1. Okay, and then I've got 4 times 2. Well, that's 8, right? Plus 1 times this. Well, 1 times 3y plus 1 is just 3y plus 1. Okay, so there's no number here. If that was a 2, you know, that would be like... Okay. 1 or 2 more lines. Bottom just stays, right? It's once you've found the lowest common denominator, it's just along for the ride, and it's got to be there. Okay, and then we've got 8y plus 8 plus 3y plus 1 gives me 11y plus 9 over, and again, right, denominator is just along for the ride. Nothing factors up top. There's no point. You know, this is it. You're done. Only 6 more. This lesson will be over. Okay. You need to do a bunch of these, right? You're not going to get any good at them unless you actually practice. Okay, now let's get you doing a little bit of factoring. Okay, first step is to factor, right? And now there actually is something to factor, right? So this has a common factor of 3. There you go. Hey, 3. 3 goes into 6 twice. And into 3 once. And oh, okay, now, wait a sec. Let's state our restriction. Okay, from the factored form, before I do any canceling, state your restriction, which is y can't be negative 6. 3 goes into 6, so I've got 2y here, plus y plus 1 over y plus 6, right? Having gotten rid of this 3, they now have a common denominator, right? If you don't cancel that, then you're going to be multiplying this by 3 over 3, making it more complicated than it needs to be, and then having to simplify it at the end. Whereas this way it's just going to be 3y plus 1 over y plus 6. Oh wait, that's a minus. Yeah, right.
Could we have the caretaker call the main office, please, caretaker?
So it's minus y plus 1. Okay, so it's going to be 2y minus 1 over y plus 6, which is y minus 1 over y plus 6. Okay, I looked at my answer down here and said, oh, you messed that up now, didn't you? So watch out for minus signs, which I apparently did not. For illustrative purposes only, not. Yeah, so just messed it up. Pure and simple. All right, so let's do another one with a minus sign. I'll let you try this one. Then you can check with the neighbor. Okay, so you got some factoring to do. Possible there might be some cancellation available to you. Or not. So first step is factor, second step is state restriction. So if you cancel these, right, if you recognize, hey, I take an x out of here, right? So it's x times 2x plus 1. Always verify, right? I get 2x squared plus x. Do I get this back? I get 8x plus 4. Do I get that back when I multiply it through? If I cancel these guys, now before you do, you have to state the restrictions, right? Restriction on this is that x can't be 0, and these restrictions, both same as that x can't be negative a half, right? But you've got that x can't be 0 there. Okay. Now that that's simplified, it makes for a simpler LCD, right? It's just 4 times 2x plus 1. And you don't have to do anything to this denominator. It already is 4 times 2x plus 1. If you had your LCD as 4 times x times 2x plus 1, then you've got a bit more work that you've done. You've got x's here and x's there. And at the end, it's got to cancel out. Okay. But if you recognize that, hey, these cancel and I can do that, I just get 1. Okay, then makes for an easier time. Oh, yeah. Okay, guaranteed type of factoring that you will see. Common factoring, which you have to do there. And difference of squares factoring. Okay, might have to factor a simple trinomial. Matter of fact, question I wrote yesterday, you do have to factor a simple trinomial. So let's start off by just factoring. Failure to factor this leads to a 10-minute solution, which is wrong, right? Like you're going to have a common denominator of 3 times x minus 9 times x squared minus 9. You're going to be doing all these multiplies that you really shouldn't have to, don't want to do, and it's going to fill the page, and it's going to be worth nothing, right? You won't get it right. You can't. So make sure you recognize difference of squares, right? Very important. Make sure you recognize the difference of squares even if there's a factor. If you get something like 2x squared, or sorry, let's say you get 2x cubed minus 18x. Okay, well, you got to factor out a 2x, and then you get x squared minus 9. And then you get a 2x and an x plus 3 and an x minus 3. Right? That's how this factors. Okay? If you don't factor, that's not the question is there. But if you don't factor that correctly, then it just all goes bad. And it wastes a lot of time. Okay, factored form. So now we can state the restrictions. So x cannot be positive 3 or negative 3. So what's the LCD now? What do I need? Need a 3. What else? Need an x minus 3. What else? Plus 3. What else? Don't need it again. I already got it. So do I have a 3 on the bottom? Yep. Do I have an x minus 3 on the bottom? Yep. Got an x plus 3 on the bottom? Yep. Do I have 2? No, I don't have 2. This is just an x minus 3, right? Well, it's already there. It's accounted for. Okay. Only if it appeared here twice. If this was x minus 3, then I would need 2 of them, right? Okay, so it becomes 4 over 3 times x minus 3. So what does this first term get multiplied by? X plus 3 over x plus 3, right? Okay, what's that going to give me? A 3, an x minus 3, and an x plus 3. That's what I need. Okay, now it's not equal, it's plus 2x, so the 2x is over x plus 3, x minus 3. So what does it need on the bottom? It needs a 3. So we're going to multiply by 3 over 3. So now, I got my common denominator, so I'm just, I'm not going to do each term separate at this point. I'm just going to say it's a common denominator. So now I've got 4 times x plus 3 plus 2x times 3, right? So I've got this times this, 4 times x plus 3, plus 2x times 3. Okay, so now we have to expand and collect and simplify the numerator. So we're going to get 4x plus 12 plus 6x over 3. Okay, at this point, the denominator is just along for the ride. So 10x plus 12. Now, 10x plus 12 factors, right, because they're both even, but there's no point in doing anything with it, right? Because the only thing that goes into 10 and 12 is 2, which would give me 2, and then in brackets I would have 5x plus 6. And it becomes, yes, so what? I mean, I can't do anything with the 2 or the 5x plus 6. They won't cancel. So then I'm not going to do anything. But here's one where you should do something. Okay, first step, factor. Second step, state the restriction. Third step, is there any cancellations that I can do? Cancellations can only be done top and bottom, right? There's no multiplier or divide symbol, so you can't do any top with any bottom. You can only cancel within a single term. Okay. When there's pluses or minuses, you can cancel anything top and bottom in the same term, which isn't going to happen in this case anyway. So. Okay, so we do have a difference of squares, 4 minus x squared. Factors is 2 minus x, 2 plus x. We can state our non-permissible values, which are plus or minus 2. You can't factor x squared plus 4, nor are we actually factoring numerators anyways. So when you add and subtract, you're not factoring a numerator, you're leaving it. Unless this did factor and it would take one of these guys out. Okay, that's the only reason I would factor numerator is if I said, hey, one of them is going to be one of these guys. You can't factor a sum of squares though. Okay, what's the LCD? 2 minus x, 2 plus x. So this one term is just going to be left alone, right? There's nothing that... it's got everything it needs. It's got a 2 minus x. It's got a 2 plus x. This other term needs something. So what does it need? Okay, so it needs a 2 plus x over 2 plus x. So I got my common denominator, right? 2 minus x, 2 plus x. I got x squared plus 4, let's leave that in brackets, minus x times 2 plus x. Okay, so minus, and then we've got this times this. That has to be kept in brackets because this minus sign is going to distribute through, making this minus 2x minus x squared. Okay. So now removing brackets from the top, x squared plus 4 minus 2x minus x squared over 2 minus x, 2 plus x. So x squared minus x squared. So I get 4 minus 2x I should say, well, 4 minus 2x, 2 goes into both of those, right? And when it does, this is going to become 2 minus x, which will then cancel. So I do need to factor the top. 2 times 2 minus x. Just check that out. 4 minus 2x. Okay, gives me what I want there. Over 2 minus x, 2 plus x. These guys cancel, leaving me with 2 over 2 plus x. And potentially you could see that written as x plus 2, right? So when you're working out a question, especially multiple choice, you got a couple of things that you're looking at, right? One is, what form are the answers in? Another is there any similarity? Do all the answers have something in common? Because if they do, then that's not a distinguishing characteristic of the answer, right? Like if they all start with 12x squared, then you don't have to worry. It means your final thing is going to start with 12x squared. Okay. Then if they start differing, that's what you're looking at. But you're also looking at what form does it take, so I know what to be looking for. Like I look at the answer for this and I don't see 2 minus x, 2 plus x, right? Like all the answers just have 2 plus x, x minus 2, 2 minus x, x plus 2. So but wait, I've got these denominators, I've got 2 of them. They're only showing 1 in an answer. It means it's going to cancel out, right? Yep. In a minute. Okay, we'll do one of these two. Jimmy swam 500 meters upstream. To his cousin's cabin. Unfortunately, Jimmy can't swim. He drowned, and then the question ended right there. Wait, how many people came to the funeral? No. No, this is actual. There's going to be some math in here. He then swam 500 meters downstream to his own cabin. Fast questions don't actually make a lot of sense in the real world, right? Sometimes. So I actually, we spent a fair amount of time yesterday, like looking for real world applications of stuff like this, and so this is not totally unrealistic, but there's a question that was on a couple of years ago that they threw out, and we asked them like, okay, why did you throw out that question? And they said because it was too difficult. And we said, well, aren't you supposed to field test these things? Like, and if it comes out too difficult, then you just don't use it. But what it turned out was that they were using like meters per second in one thing and kilometers per hour or meters per hour in another one. Like they mixed up the time measurement was in different units. So most kids didn't catch that, and that's why less than 20% of the kids in the province got it right, and so they tossed it, right? Because it's just, it's too hard a question. So, should you see one, you probably won't have to switch units, right? But you might see them in the textbook, so just be aware. It might give you a time minute that says this happened in so many minutes, but the car is traveling in kilometers per hour, and you just have to make sure that everything's in the same units, either all in minutes or all in hours. This won't happen in this question because it's been very carefully designed. The speed of the river was 100 meters per minute. assuming that Jimmy swam at a constant speed, right? So Jimmy's got a speed. If he's in a pool, there's a speed at which he swims. Okay, nice constant speed. He's a triathlete, right? They just swim at a constant speed. Okay. Now, if he's swimming downstream, is he going faster or slower? He's going faster, right? Because he's got the current with him, and if he's going upstream, then he's going slower. So assuming Jimmy swims at a constant speed, write a single rational expression that represents the total time of his swim. Running out of ink. The total swim. Okay, so we're not solving this, right? We're not asking what was the total time. I mean, that's like tomorrow, I think we do solving rational equations. We'll touch on a bit. Okay, so we have a distance, 500 meters. We have a speed of a current. We've got a speed of a Jimmy, and we've got time. Right? So what's the relationship between distance, speed, and time? So okay, how fast should you be driving to Edmonton at, let's say, 100 kilometers an hour? How long does it take to get there?
5 hours.
Edmonton, not Great Falls. Okay, it takes 3 hours to get there. You're driving 100 kilometers an hour for 3 hours. You're going 300 kilometers. What's the relationship between distance, speed, and time? The 300 kilometers is equal to the 100 kilometers per hour times the 3 hours, right? So distance is equal to speed times time. So what's time equal to? Distance divided by speed, right? That's just a little rearrangement of the thing. Okay, so we got Jimmy, and he's swimming upstream, so he's got a distance of 500 meters. He swims at a speed of x, so we should say let x be Jimmy's swimming speed. Let x be the speed at which Jimmy swims. So if he's going upstream at x, but there's a current of 100, then what's his speed? So he's swimming x, but there's 100, which is going which way? Towards him or behind him? Is it pushing him or holding him back? Swimming upstream. Holding him back. So it's going to be x minus 100, right? Whatever his speed is, he's going to be slowed down by 100 because that's the current. When he swims back, current's at his back now, right? Behind him. So what does that do to his speed? Increases it by 100. So now his speed is x plus 100. Okay. So if we were going to turn this into something that you could solve, we would then say the total time was so many minutes, and then you would solve for x. Right? All we're doing is just get a single rational expression. Okay. So you start off by saying, well, x is neither positive nor negative 100. Right? Because if it were, then he'd have a speed of 0 at some point. He really wouldn't be going anywhere. The LCD is what? It's minus 100 times x plus 100. Need one of each. So the 500 over x minus 100 gets multiplied by x plus 100 over x plus 100. And the 500 over x plus 100 gets multiplied by x minus 100 over x minus 100. So on the bottom, we got x minus 100, x plus 100, and up top we've got 500 times x plus 100 plus 500 times x minus 100. So it's going to be 500x plus 50,000 plus 500x minus 50,000, or just 1,000x over. So 500x plus, I guess that's just 5,000 plus 500x minus, it's 50,000 over. So it's 1,000x over x minus 100, x plus 100. Okay, and that's the single rational expression which we are not going to solve.